Hi students, this is Alex here. In this video, we are going to solve a partial differential equation. The question is in the form of z equal to px plus qy plus a function in terms of p and q. So, to get the complete integral, we take p as a and q as b. So our z will become ax plus by plus c is a constant root of a square plus b square plus 1. Let's keep this as our first expression. Now to get the singular integral, we have to differentiate the first expression partially with respect to the constant a. So z differentiation is 0, a differentiation is 1 and the constant x will be as it is. By is fully constant, so it is 0. C is a constant which stays as it is. Square root differentiation is 1 by 2 root a square plus b square plus 1 into differentiation of a square is 2a. You can cancel this and take this x to the other side. So minus x is equal to ca by root a square plus b square plus 1. Then by cross multiplication we can get the value of ca, which is minus x root a square plus b square plus 1, and a will be minus x by c root a square plus b square plus 1. We shall keep this as it is. In the same way, we take the first expression, differentiate partially with respect to b. So z differentiation is 0, ax is fully constant, so 0, b differentiation is 1, and y is a constant, stays as it is, c is a constant which stays as it is. Square root differentiation is 1 by 2 root a square plus b square plus 1 by chain rule into 2b, because we have to differentiate this term. You can cancel these two and taking this y to the other side, minus y equal to cb by root a square plus b square plus 1. By cross multiplication we get cb as minus y root a square plus b square plus 1, and b is minus y by c root a square plus b square plus 1. After this, we are going to substitute both a and b in z. Z is ax. So in place of a, we have minus x by c root a square plus b square plus 1. I am using the first expression in which I am using the value of a, z equal to ax. In place of a, I substitute a value. Then again we have into x, I put whole square. Then plus by. b is minus y by c root of a square plus b square plus 1 into y. So I take y square. The last term is c root a square plus b square plus 1. So we can take root of a square plus b square plus 1 common. Along with that, I can make this as c square and by c, so that I can take whole divided by c also common. So the remaining is minus x square minus y square and plus c square. Now we have to get the singular solution in terms of x and y, but we have a and b. So I have to find the value of 1 plus a square plus b square value. So let's take a square value here. 1 plus a square is, by squaring this, x square by c square, and x square by c square and we have a square plus b square plus 1. So we have from this. In the same way, for b square, it is y square by c square into a square plus b square plus 1. Now, let's take these two terms to the other side so that we already have 1 plus a square plus b square minus x square by c square into a square plus b square plus 1 minus y square by c square into a square plus b square plus 1 equal to 1. Now we can take 1 plus a square plus b square common. So we left with 1 minus x square by c square minus y square by b square, c square equal to 1. Now totally, by taking LCM, which is c square, we get c square minus x square minus y square, and here we have 1 plus a square plus b square equal to 1. So from this we got 1 plus a square plus b square value as c square by c square minus x square minus y square. Now we are going to substitute in z. In place of root of a square plus b square plus 1, we are going to replace this with square root. When I take square root for this, it will become c by root of c square minus x square minus y square, and along with that we also have one more term. This, if I rearrange, we get c square as first, then minus x square minus y square. So this is c square minus x square minus y square. Now we have same term, so by cancelling these two, we left with only root of c square minus x square minus y square. So z equal to c root c square minus x square minus y square. Now squaring on both the sides, we get z square is equal to c square into c square minus x square minus y square, and by dividing this, z square by c square equal to c square minus x square minus y square, and in the z also we had a term by c. So this term should be taken here by c, and once again here that c and c we can cancel, because when we replace there is also in division by c. After cancelling this, this term will not be there at all. So when I square, there won't be any c square term. Now finally, bringing these two negative terms to the other side, we get x square plus y square, and we have z square here, that is equal to c square. This is our singular solution. So we got the singular solution. Now to get the general solution, we have z as ax plus by plus c root a square plus b square plus 1. In this, let's replace b as a function of a. So our z will be ax plus phi of a into y plus c root a square plus phi of a whole square plus 1. Let's keep this as our second expression, and we are going to differentiate this second expression partially with respect to a. So z differentiation is 0, a differentiation is 1, and the constant will be as it is. And phi of a differentiation is phi dash of a, and the constant y will be as it is. C is a constant which stays as it is, into square root differentiation is 1 by 2 root. The rest of the terms should be written as it is. And by chain rule, differentiation of the terms inside the square root, 2a plus 2 phi of a into phi dash of a. This is our third expression. Now from 2 and 3, eliminating a, we get general solution.